My name is Nikhita Singh, and this is Ishaan Grover. We're both from the MIT Media Lab at the Personal Robots Group, and we'll be presenting a paper that's a little bit different than everything else that was presented in this session, but it's called P2PSTORY, which is a data set of children as storytellers and listeners in natural peer-to-peer interactions. So to give you some motivation for where this work started, it really stems from the idea that narrative skills in young children have been found to be foundational in shaping language development and predicting future academic success. More specifically, if you look at learning differences in preschool and kindergarten around the ages of 5 and 6, they've been shown to predict differences in reading ability and language comprehension later on in middle and high school. To bridge this gap, a range of different technologies have been developed from things like virtual agents and tablet tools, as well as social robots, to act in this educational context. Recent studies have also shown that if these technologies position themselves as peers rather than tutors, you get enhancements in students' confidence, engagement, as well as their communication skill development. So if we think about these technologies acting as peers instead of tutors, it's important and relevant to consider how we actually act as peers in our human context. So if we think about a peer-to-peer interaction, we can largely put it into these two roles of there's a speaker and we have a listener. And the speaker's role in the interaction is to engage the listener, negotiate the turn-taking, garner their trust, and also provide the communication context in which they're operating. On the listener side, the listener needs to show interest. They need to indicate that they're paying attention, they're understanding what's going on, and they also need to maintain and regulate the actual interaction. To successfully do this, both speakers and listeners use a range of cues. So speakers use speaker cues in the form of changing pitch, making eye contact, or having pauses in their speech, and listeners use listener responses, such as nods, smiles, or gazing at each other. The ability to express these different behaviors has been shown to be very beneficial for enhancing engagement, attention, as well as recall. So if we think about our technologies playing these roles of story listeners and storytellers, we need to be able to play the role but also express these behaviors when we do so. To give you some additional context, a range of different technologies as story listening technologies and storytelling technologies have been developed in this space. This has taken the form of robots that can backchannel, robots that can exhibit cues when they're storytelling. This has also taken the form of embodied conversational agents, as well as things like a story mat or digital platform. When designing these interactions, HCI researchers typically pull from social psychology literature or looking at data sets or looking at real-world dynamics to influence the way the technologies behave. Now, interestingly, there's several data sets of adult-adult dyadic interactions. Examples of this would be Alico or Multilis, if you're familiar with the space. We also have data sets of adult-child interactions, so things like MMDB or EmoReact have been developed in this space. However, there's no prior work, to the best of our knowledge, that exists in capturing the natural interactions of young children amongst their peers at their own age. In addition to this, there's very little knowledge of the social dynamics in peer-to-peer contexts for children. Now, this is particularly relevant as nonverbal expression happens during childhood, particularly in this age around 5 to 6, so it's meaningful to understand these differences in expression between adults and children. So in this light, we present P2PSTORY, which is a data set of children ages 5 to 6 years old engaging in seemingly natural peer-to-peer storytelling with fellow classmates. With that, I'm going to pass it over to Ishaan to dig into the methodologies and analysis surrounding the data.
So we recruited 18 kids from a single kindergarten in Boston, and they were supposed to perform a storytelling task. As you know, a storytelling task consists of a storyteller and a listener. In the context of our data set, a pair of storyteller and listener forms a dyad. So each child participated in 3 rounds as a storyteller and a listener, which formed 58 interactions or 58 dyads. The methodology that we used for data collection took place in 4 phases. The first phase was the instruction phase, where a proctor reviewed good listening skills with the child who's going to tell the story. The second phase was the story construction phase. In order to avoid hampering of social dynamics just because a child is not able to form a story, or the child is unable to do the task properly, The proctor took the storyteller in a one-on-one session, formed the story with the child, discussed the characters that should be there, the progression of the story, and so on and so forth. So the child was ready to tell the story. The next phase was the story sharing phase, in which, as a storyteller, a kid was asked to make sure that their partner was paying attention to them, they were understanding them, and as a listener, a child was asked to pay attention to the storyteller because he would be asked to recall the story in a later phase. After this, the proctor left the room and the children were free to interact with each other the way they wished. The final phase was the recoil phase, where listeners were asked to recall their partner's story to the best of their abilities. Each child was also supposed to rate their partner's abilities in storytelling or listening, depending on what role they themselves took on. The study setup had 3 cameras that were recording from different angles, a high-quality microphone, and a storybook to give the context for the story that was going to be told. Here's an example of one of the interactions.
One day the girl had her first day of school. The cat wanted to be with her, so the cat broke the window and then it ran through school and peeked inside. They saw classmates and then jumped back through the window and back to the
So after this, we annotated for listener and storyteller behaviors. So some of the listener behaviors that we annotated were nods and gazes. Some of the storyteller features was the pitch high, were they using a filled pause, were they saying things like or so, were they using a silent pause. Apart from this, we also annotated some task-related features. So was the kid on or off task? Was the kid paying attention to the story? Things like that. And here is a visualization of this annotation.
Once upon a time, there was Allison and Joe and Alice.
Right. So the table, this table shows all the possible values for the features. So, for example, gaze, I could be gazing at my partner or at the tablet, or I could just be looking away because I'm a kid and I'm probably not paying attention. I don't know. There could be gaze, posture, which is am I standing upright? Am I sitting upright? Am I leaning towards my partner? Things like that. So some simple analysis on this data revealed some very interesting facts about storytelling among children. So in the table, the values to your left are rate, which talks about frequency of gesture per minute, and the values to your right represents the proportion of time that is spent in the activity. So it's really interesting to see that listeners gaze very frequently, but not for very long periods of time. So they're just looking and looking away. They smile and lean towards the storyteller less frequently, but when they do, they hold their position. And something that was really surprising to me was, unlike adults, children don't really nod a lot. And even when they nod, they nod for very short periods of time. As adults, we usually look at each other and we nod and tell each other that we're understanding. I see people in the audience are still nodding, so we're all adults. But in the interactions, only in 17.2% of the interactions were nods even seen, and even when they were seen, they weren't very frequent. As storytellers, children use high pitch the most to capture a listener's attention. It was also surprising to see that when they get stuck, they use silent pauses a lot more than filled pauses. So they don't really say or a lot, which is very surprising to me. So all in all, This data set consists of a time-synced audio-video from 3 different angles, behavioral features like gaze, brow raise, etc., prosodic features for the storyteller, so was the pitch, high, energy, pauses, and so on and so forth. We also have demographic features and some social developmental features in the form of ASQ scores. Finally, we have perceptions of children of each other as storytellers and listeners.
Great. So to give you some context on where we see this data being particularly valuable, there's sort of 2 broad areas where we think it can be used. First, on the analysis side, it can be used in order to evaluate how children interact with each other, looking at peer-to-peer interaction and digging into the nonverbal behavior expression. To give a taste of this, in our paper, we start to look at how adults and children's perception of attention are actually quite different and the features that are salient to both. In doing that, we find that adults' perception of attention tends to be a function of things like brow raises and nods, whereas children's perception of attention is a function of leans towards the partner, smiles, and gazes. Digging into it even more, you find that the duration and the rate of these features being present also has an impact on how we perceive attention. So adults, for example, if I nod a lot, they don't see that as being attentive. But if I nod thoughtfully, that's very different. Similarly with kids, if you sustain your gaze for long periods of time, that's more correlated with attention versus looking away and back and forth. So this is sort of just to give you some context on the types of analysis that can be explored. In addition to that, as Ishaan mentioned, there's also demographic features and social emotional development features for each of the children. So the goal with that is you can start to explore differences across children since each of them took part in multiple interactions with multiple partners to see how those might impact the way that children behave. On the other side, there's also the models that can be used to power educational technologies. So far, this data set has been used to build 2 separate types of models. The first has been a POM-DP model in order to predict children's attention, and the second model was a back-channel opportunity model that was then run on a social robot in order to see if it enhanced recall and engagement from children. So of course, you're more than willing to use the data as you please, but these are broadly the spaces that we thought to be most relevant to mention. In terms of accessing the data, we made it public for academic institutions. So it's currently available at the Media Lab website. You can search for P2PSTORY. There's instructions on how to send a data use agreement and get access to the data. And then we're happy to obviously answer any questions or thoughts that you might have.
We have time for quite a few questions. Because this was shorter presentation that good. Yeah. So, yeah.
Thank you. So I'm Elisa from University of Lincoln. Thanks a lot for your presentation. I wonder if you have considered the fact that your sample just included American children, if you consider to include different sample, because as you know, the way we communicate depends a lot on the cultural background where we belong to. And I have a second question about if you have any challenge, have you identified any challenge for designing technology which is not based on robots but maybe on tablets? Because kids at this age, they might want to use different kind of devices. So thanks a lot.
Yeah, so in terms of the cultural question, definitely, like even looking at literature in the space, there are differences, of course, in nonverbal behavior expression, especially at this age since it's developmental. That tends to be a function of what you're surrounded by. So our sample did only include Boston kids. We tried to have the developmental and demographic features put into that in order to look at some set of differences that may exist. But of course, that's not representative of the broader context. That also being said, I think in literature there is some consistency across, humans in general and the way that we develop in terms of our nonverbal expression. So I think our goal is that it can help supplement some of that. In terms of the second question, I think there's been several projects that have taken on like a tablet or interactive form and leveraged some of these principles. Some of them have had things like, a stuffed animal that goes with the tablet, or having some sort of embodied state. And of course, that's more relevant when you're looking at, the physical expression of these behaviors. But there's also been a lot of embodied conversational agents in a virtual form. So, a character that's in a storybook or a character that's leading you through something in a tablet has also been used. So that's another space where you could leverage a tablet for the.
Thanks a lot.
I have also a question. So, in the future, now that you have the data set, so are you looking for people to partner with in order to, for instance, as the previous kind of question was pointing out, you could have data sets from different parts of the world, for instance, and you could find similarities between them. So what are your kind of future plans for extending possibly the data set or to analyze something that you haven't done this far?
So, feel free to add.
Yeah. So one of the things that we were looking at was, can we predict if a child is going to continue paying attention, if just based on their behaviors. So if I'm a robot and I'm looking at a child, I'm talking to the child and the child starts looking away. This is social context. We know that the child is probably now not paying attention. So can we predict whether a child is paying attention or not based on this? So we're starting to look at that, and you build some models using machine learning to see if that is. But that is one of the areas we're going towards.
Or if possibly you could start collaborating with the University of Lincoln in order to have a data set also.
Yeah.
Certainly. Yeah.
But okay, do we have one more question?
Yeah, it's well, I can see that the data set has been in here for some time because you've clearly had papers in 2017 using this data set. In the papers you've used, you've used this, it's a very, very rigid system because you've got the two children kind of facing on around this one book. In reality, when children tell stories to one another, they may be in all sorts of different positions. They might have props in their hands. They might have the teddy bear or they might have something else. So how would you go about getting that kind of material, or could it even be done using the methods that you've used, which are very sort of, it's very, very closed down, it's very controlled? Do you have any thoughts on how you could do it with all this other stuff?
Yeah. So I think the goal of having some of the story construct there in order to guide the interaction was to have some focus. In terms of getting completely free flow interaction, that's typically hasn't been done in the data set space just because you want consistency across what you're evaluating. But I do think a similar methodology could be useful in exploring that. One of the things we looked at was round differences. So, making sure to pair each kid with different genders, also pairing them with kids who they were familiar with versus not as familiar with. So trying to tease out some of the things that make interactions natural, I'm going to be more friendly with someone I'm friends with and maybe tell different stories than someone that I don't talk to as much in my class. So in the data set, we do explore some of those ideas. And so, theoretically that can be extrapolated, but there's always that trade-off between wanting to create something systematic that can power a model and, putting the scaffolding around it, and then wanting to be completely natural in the way that we gather the data.
So you haven't got a plan at the moment to make another data set then?
So as a group, we have a series of different kind of data sets that we have developed over time for particular use cases, but none of it has been a corpus that we've been able to put out. So specifically in terms of a plan to extend this to very natural interactions, there isn't one right now. But in terms of the interactions that have been tested through this data set, for example, the papers that were put up there, those could potentially in the future be used as another,
Okay, thank you for attending. Let's give a big hand for all of you.